Dinesh Kumar, are the slides visible? Dinesh Kumar, are you there? Dinesh Kumar, are the slides visible? Sachin KR? Sachin KR.
Yes, sir. Yes, sir.
Okay, is it audible?
Yes, sir.
Okay, fine. So in the last period, we had started module 4, and module 4 is the file systems. And like the next topic in the continuation of module 4, so we have basically two kinds of files, and those are structured file and byte stream file. And in the last video, we had seen the structured file, right? Structured file is a file that is the collection of records and fields, and the meaning of record and fields are being analyzed in the last period itself. So where the record is a meaningful information of related fields, where each and every field is containing so one single data item. Okay, so for better understanding, along with the example given in the book, say the employees information. Okay, so we had the employees information having these many fields. Okay, so the records of the employees will be having these many fields, namely the ID number of the employee, as well as the name of the employee and the position held by the employee in the organization, as well as the age of the employee. So a record will be having these many fields. And for your better understanding, another example was also discussed. So where the IM marks of the students can be maintained as a file. So where the file is having the collection of records. And according to this example, here we can find two records. Okay. So one record is of Rama and second record is of student Shama. So for example, and this record has got various fields. Okay, so the three fields available are serial number and name and the average marks obtained by the students. Okay, so where each and every field is containing one single data item. Okay, so this example was discussed in the last class. And regarding the next kind of file system is the byte stream file. Okay, like it is simply a collection of bytes. So as the name itself indicate, byte stream file is nothing but simply the collection of bytes. Like as you can see here, right? So we have some characters, or we can have the stream of bytes or the collection of bytes. Like everything is being seen or viewed as a sequence of bytes. Okay, and it will not differentiate between the information and the data. Simply each and every information, each and every data, right, will be treated as a sequence of bytes. Okay, and our Unix operating system uses this byte stream files to store the data and programs. Okay, so you can write down this particular example. So for the byte stream file, so where again I repeat, it is simply the collection of bytes and everything is being viewed as a sequence of bytes. Okay, so you can explain this structured file, right, along with the example given in the book. Okay, and for a byte stream file, so you can take the help of this particular example. Okay, so next is regarding the operations of the file. Okay, on the file, so what all operations can be performed. So these file operation will be able to describe the operations performed on the files. And we know that so this OS is responsible for creating and maintaining a file. Okay, and so you can recall the meaning of the file and like the different types of files, right? An example for a file. Okay, all were discussed in the first slide itself. Okay, so now coming to the file operation. So this file operations will be describing the operations that are being performed on the files. And this OS is responsible for creating and maintenance of the file. And see to that these files will be accessed by the users only in accordance with some access privileges. Okay, so we can have the access privileges to be offered by the user to any file. Okay, so for example, accessing the file, read operation, write operation to be done on the file, or say deleting the file. Okay, so when requested by its user or creator. Okay, So these functions of creating and maintenance and protection and deleting a file, right, is done by this file system interface. Okay, and here are the list of the operations that are being performed on a file. So, for example, opening a file, reading or writing a file or a record, or closing a file, or making a copy of the file, or file deletion, file creation, as well as renaming a file and specifying the access privileges. Okay, so let us discuss these operations one by one. So regarding this opening a file, okay, so the first operation on the file is opening a file, right? So you can explain the opening of a file something like this. So a process needs to execute this open statement before it can do any operation on the file. Okay, so this file system will be able to execute the open statement before it can do any operation on the file, right? So the file system locates the file and checks the user executing the process has got all the necessary privileges or not. Okay, so the process does perform some operations, actions, right, upon opening the file using the open statement or executing the open statement. Okay, so next operation is reading or writing a record or a file. Okay, so the process will be able to issue the command to either read or write a record. Okay, so the file system will consider the organization of the file. So again, the word organization of the file means the way in which the data is being stored in a file. We call it as organization of the file. So the file system will consider the organization of the file and implement the read and write operation. Okay. So now third operation is closing a file. Okay. So this closing a file indicates that so this closing of a file is indicated by executing the close statement, like similar to the open statement executed. So whenever the user wants to do some file operation similar to that, so for the closing of a file, so this closing a file is indicated by executing statement, close statement. Okay, that is execution of the close statement indicates the file system that the processing of a file is being completed. Okay, so the file system will update information with respect to the size of a file and the number of records stored in it, and also its data structure. Okay, so this closing the file is simply indicating the execution of the file is been completed, or the file processing operation is been completed, and that is indicated by execution of a close statement. Okay, and we have something called as file creation as well. So to create a new file, so we need to do two steps. Okay, so the first step to have the file creation is to find the space in the file system where to create a new file. Okay, so you must be able to find a new space, okay, in the hard disk where I want to create a file. Okay, and second step is make an entry of a new file in the file system. So the file system will be able to store information with respect to the size of the file, okay, in its data structure. So we do have something called as file creation operation as well. And next is the file deletion. Okay, so this file deletion, where the file is deleted from the directory structure of the file system. So we first open the file and delete. Okay, so to have any of the operations to be done on the file, so first I need to access the file. So we first open the file and then we can delete it. So by delete, we will close. Like suppose if I go for the delete operation means like we'll be able to lose the contents of the file, okay, as well as all the file attributes will be also lost, right? So this is the like one more operation, file deletion, and next operation is file renaming. So the file system remembers the new name of the file, right, in its directory structure. So you can also go for, like, any user can also go for the renaming of the file, and upon doing so the file system will be able to remember the new name of the file in its directory structure. And regarding the last operation of the file, that is specifying the access privileges. Okay, So the last operation of the file is specifying the access privileges. So the user can change or the user can give some access privileges of a file, okay, that is created by his process, right? So at any time during the file lifetime, right? So the user can change or can give some access privileges, right? So for his file, what is created during its whole lifetime, right? Okay. So basically, like these are the different file operations. Okay. So you can explain this like using some sentences, or you can simply have it like in terms of a tabular column. And according to the module 4, like this can be one of the important questions. Explain all the file operations as well as the different types of files. And basically, you can find here two types of files: structured file and byte stream file. Okay, and you can refer to the example according to the book, and this example can be taken as for better understanding. Okay, so but I insist you to write down the examples according to the book. Okay, yeah. So next is the file system organization. Okay, so this file system organization is the next topic. So what do you mean by this file system organization? Like it means how the data is arranged or stored in a file. Okay. So based upon this particular concept, we can have basically three kinds of file system organizations. And those are sequential access file organization. Second one is direct access file organization. And third one is index access file organization. Okay. It is also called as indexed sequential access file organization, or simply indexed access file organization. So the file system organization meaning can be taken as how the data or the information will be arranged or stored in a file. Okay, so basically this file system organization will be able to define as two things with respect to a file, and those are arrangement of records in the file system. Okay, how the files, how the information, how the data, or how the records will be arranged inside a file system. Okay, so what do you mean by a file system? Basically, we know the meaning of file, but what is a file system? File system is nothing but the collection of files as well as the directory structure. Okay, so while dealing with the first line itself, like we have seen the definition of file system, where the file system is the collection of files as well as the directory structure. Okay, so now with respect to this file system organization, so this file system organization will be able to give the information regarding the two things with respect to a file. One is arrangement of the records or information or data in the file system, and second one is the procedure used to access the record. Okay, so based upon these two things, we can have three types of file system organizations. Okay, so one is sequential access file organization. Second one is direct access file organization, and third one is indexed access file organization. So let me deal with the first kind of file system organization, that is sequential access file organization. So according to the figure, the example, here I can find the employee's ID. Okay, so where the employee's ID is been arranged in which order? According to the numerical values, employee's ID has been arranged in ascending orders. Okay, so the records are stored in ascending or descending sequence according to the key field. Okay, so what do you mean by this key field is, say, like I can have this employee's ID right as the key. Okay, and all the records will be arranged based upon the, say, ID of the key. Or if I take the example of a class, means so you can have the USN as the key field. Okay, so here based upon the USN numbers, I can arrange all the students. Okay, so these USN numbers or the employee's ID, or say based upon the age of the students, I can have the arrangement of all the students like either in ascending order or in descending order. Okay, so this ID is nothing but so one attribute of the records. Okay, so you can have this ID of the employee, or I can have the age of the employee. Okay, so this age or ID number. Okay, or say based upon the caste also, I can have the arrangement of the students or the employees either in ascending order or the descending order. Okay, so the basic point here is, like in case of this sequential access file organization, the records are stored in an ascending or descending sequence according to some key field, like as I told. So this key field can be the employee's identification number or the employee's age, okay, or the employee's say like years of service in the organization, right, etc. Okay, so based upon some key field, the records will be arranged in either ascending order or in the descending order. Okay, and according to the example given in the book, here we have the records of the employees where the ID is acting as the key field, and based upon the ID of the employees, these records are arranged in which order? Anybody? Are you seeing this sequence of records arranged in which order? First record is 1, second order is 2, third order, I mean, third record is 4, next record is 10. Like all these are the employees' IDs. These IDs are arranged in ascending order, right? Ascending order. Okay. So as the name indicates, the records are accessed sequentially. Okay. As you can see here, the name itself indicates sequential access means all these records of the file, okay, where the records are being arranged in the ascending order based upon the ID of the employees. Okay. So the access is also made in the sequential manner. Okay. So the records is accessed one after the other, okay, starting from the beginning of the record to the end of the record. Okay, so the random access of the record is not possible. Why? Because the access will be made in the sequential manner, one record after another record. So for example, like I cannot access this record of the employee having the ID 4. Why? Because so to access the record of the ID 4, okay, I need to first access this one, right, employee ID of 1, and next I need to access the second, and then I can access the fourth record. Okay, directly I cannot access the fourth record. Okay, so all the records are organized based upon some key value. Okay, so what is this key field or key value? So you can consider the roll number of the employees or the USN numbers of the students, or the employee's ID can be acting as the key field. Okay, so to understand like the significance of this key value, okay, like here I've just modified the same example. Okay, so for better understanding, right? So like according to the figure, so you can have here 3 number of records are there. Which are they? So the say that students by name Rama is one record, and Rama, Raju, and Sham are the 3 records. Okay, like belonging to the 3 students. So by name Rama and Raju and Shama. And each student have got the roll numbers, where 001 is the roll number of Rama, and 02 for Raju, and 03 for Sham. Okay, so here these records, record 1, record 2, record 3 are being arranged based upon the key field. And here I considered the key field as what? What is the answer? These records of students Rama, Raju, and Sham are being arranged based upon one parameter, based upon one characteristic, which is that based upon the roll number. Okay, so the roll number 1 is for Rama, and roll number 2 is for Raju, and roll number 3 is for Sham. Okay, and these records are having how many fields? So record 1, record 2, record 3 are having how many fields? 3 fields. Where the first field, I mean, so you can have the ID or the USN number of the student, and next field is the name of the student, and third field may be the age of the student. Okay, or you can take these as employees as well, no problem. Okay, so here we have 3 records, record 1, record 2, record 3, and all the records are having 3 fields. So for easy manipulation and retrieval of data, so one or more field is considered as a key field. And according to the example, here the USN or the ID number of the employee can be acting as the key field. So for retrieving the record number 3, okay, I cannot access record number 3 directly. Why? Because it is what kind of access? Here it is what kind of access? Sequential access. Hence, to access the record number 3, okay, I need to move along the record number 1, and then I can access record number 2, and after that only I'll be able to access the record number 3. Okay, randomly or directly, I cannot access this record number 3. Why? Because it is a sequential kind of access. Okay, and this can be one of the main problem with respect to sequential access, where directly I cannot access any record, or random access of any record is not possible. So for retrieving the record number 3, we need to traverse, okay, or we need to travel along the records 1 and 2, and then I can access the record number 3. Okay, so all the files or records are stored in like on the hard disk. So we need to access them in a sequential manner. Okay, like here you can find basically two kinds of operation. Okay, so one is read the next or previous record. Second one is skip the next or previous record. Right, and these names are self-explanatory. Right, read the next or previous record. So what do you mean by this? Suppose if I'm say reading the second record, means I can also read the fourth record, and also I can read the first record. Okay, so here like two kinds of operations are seen here. So first one is read the next or previous record. Second one is skip the next or previous record. Okay, so the uses of it. So the main use of this sequential access file organization is, so when data can be conveniently pre-sorted into an ascending or descending order, then we can easily go for this kind of sequential access file organization. And so basically for the byte stream files, as we know that, so these byte stream files are nothing but collection of bytes. Okay, so for those kinds of files, you can go for a use of this sequential access file organization. Okay, so you can explain this along with this particular the figure or example according to the book example. Okay, where we have arranged the records in the ascending order, and I can access all these records one after the other, and random access is not possible. And we can have the arrangement of these records based upon some key field or key value, and that key value can be either the roll number of the student or the ID number of the student, or say based upon the age of the employee or the student also you can arrange the records. Okay, so next is direct access files. So this direct access file, like as the name itself indicates, like this allow to access the records of a file in the random manner. So the disadvantage what we had in the sequential access file organization, that can be solved in this direct access file organization. How come? Because it allows the access of the records of the file in a random manner, means directly I can access the third record or fourth record or the 10th record. Hence provides convenience or efficiency of file processing. Okay, and the files are called as direct access files. Okay, so you can take the example of this particular figure, like where we have the records 1, 2, 3, 4, 5, and I can access any of the record directly. Right, any record can be accessed randomly or directly. No need to move or transfer or traverse or travel in the sequential manner. Okay, so you can have some examples on it. So the direct files are also stored on the hard disk. So to access a record, like either you can have the read operation or write operation. Okay, so to access any record, we need to only mention its key value. Okay, so just by providing the key value, you can access or you can write or you can read any of the record, right? So when a process provides a key value, the access method for direct file organization will apply a transformation to the key value. So here one transformation function will be able to generate the key value, and this key value will be giving information regarding the track number and the record number. Okay, so here based upon the transformation, okay, done on the key value, right, it will be generating the track number and also the record number, means the address of the location to be accessed is found. Okay, so the head of the hard disk will be positioned on the particular track number and the record number, so that that particular record can be accessed. Okay, so you can find here suppose if you have a sequence of records here, right? And so for example, like let me take the records as a student information, where the student information or the record is been like having the roll number is been stored here. Okay, so for each and every student, say for example, information like what we need is say 10 bytes. Okay, so for each and every student, okay, we are reserving 10 bytes of information. Okay, so here based upon the key field, the OS will find the location of that record. Say for example, so for accessing the third record, right, and the third record is here, and like as I told, each and every record is of size how many bytes? 10 bytes. So
Right.
1 to, yeah, so 1 to 10 bytes are reserved for record 1 or student information 1, and 11 to 20 bytes are reserved for student 2, and 21 to 30 are reserved for the third record. Okay, so suppose if I want to access the third record, means what I'll be doing, I'll be accessing the bytes from 21 to 30. Okay, so like along with this information, second information, main information is we need to go for a use of some dummy records as well. Okay, so need to store some dummy records as well. Okay, and all the records must exist. Okay, so the main use of dummy records is, even though this say this field number 4 is empty, so but still I need to have some value for the record number 4. Why? Because that will help you in the transformation function, where we are able to generate the track number and the record number. Hence, even though like this particular record is empty, so but still I need to fill it with some dummy records. Okay, so need to store some dummy records. Why? Because all the records must be existing. Say if third record is not there, even then we need to store some junk value of size 10 bytes. Okay, why? Because so to access the location based on some calculation, so here we can access either third record or 10th record, and this accessing of any record in a file will be based upon the transformation function. Okay, so using this transformation function to the key value, we'll be able to generate the track number and the record number. So to have this transformation or the calculation of the track number and the record number, okay, even though some records are empty, so but still I cannot leave them empty. Okay, so those records must be filled with some junk information of size 10 bytes. Why? Because here we are supposed to have the access to the particular location based upon some transformation function, right, on the key value. Okay, hence the main point here is, like as you can see the figure itself, here they have used some dummy records. Okay, so also mention this point in the direct access file organization, where as the name itself indicates, the records can be accessed directly. The records can be accessed in the random order. No need to follow a sequential kind of accessing. Okay, as we saw in the sequential file organization. Okay, and second main point is use of this use of this dummy records. Okay, so again the disadvantage here is the record address calculation consumes more CPU time. So why more CPU time is involved here? Because the actual location of the record will be calculated based upon the transformation function done on the key value, so that we can give or have the track number and record number. So to have the transformation function, okay, the CPU will take some amount of time. Hence, here the record address calculation will be consuming some amount of CPU time. And second disadvantage is some recording capacity of disk is wasted. Okay, so why it is wasted? Because here we are using some dummy records as seen in the diagram. Okay, hence these dummy records will be able to consume some disk space. Hence, some space of the disk will be wasted. So what is the bottom line? The second kind of file organization is direct access file organization, and I can explain this using this particular diagram. Okay, yeah, and The last one is the indexed sequential file organization. Okay, so for that you can have the figure 1, figure 2, and figure 3. So first understand the meaning of this index file. Okay, so like what do you mean by index file? And before going to the index file, so you can see one simple example. Okay, suppose if you have a large book having say 100 number of pages, means how to recognize say chapter number 4 or chapter number 5. Okay, so the easiest method is select. What we'll do is first we'll be looking at the index page where we can have the actual chapter name along with the page at which I can find the chapter, particular chapter. Okay, so the easiest way is to go for the index page so that I can search easily the required chapter as well as at which page that particular chapter is starting. Okay, so here, based upon this particular concept, you can see or observe this indexed sequential file organization. So let's know the meaning of an index file. So this index file is made up of a data file. Okay, and this data file is a basically a sequential file. Okay, and also we have an index. Okay, so what do you mean by this index is index can be compared with the index page or the content page. Okay, like at the starting of every book, you can find the content page, right? Okay, so what is the main use of content page? That will be showing us the page number along with the chapter number, where any user can find the location of all the chapters and their respective pages. Okay, so an index file is basically a data file. Okay, so this index is used to identify, right, a section of the disk that may contain our desired record. Okay, so the main intention of this index page, similar to the content page like in any book, the index page main use is to identify in which section of the disk, hard disk, our file or our record is existing. Okay, so now see this. Suppose in our book, right, you need to say access one particular chapter number 5. Okay, so the location of the chapter number 5 can be searched by seeing the index page or the content sheet, right? So this is a very much easy approach, right? Instead of searching one after the page, right, up to 100 page or 1000 page. Okay, so let's see. Suppose like in our content sheet itself is very large. Okay, let's assume that. Suppose if the content sheet itself is say 100 pages. Okay, that means that the book is very much large book, right? Huge book it is. Like say having say like 1000 pages. Okay, like in that case, the content sheet or the index page itself becomes large. Okay, like that is, if our book itself is large, okay, so you can have content sheet itself maybe 100 pages, right? And in this case, we go for the higher level indexing. Okay, so this higher level indexing means what? Index to index it is, or content to content, right? Understand this. Okay, so here this higher level index will be coming into picture if our content sheet or index itself is having say 70 number of pages. Okay, like in that case, I'll be going for this higher level indexing. That this means what? Index to index or content to content it is. Okay, so now like let us see this first figure. So this first figure is indicating the higher level indexing, means it contains the entries for the group of tracks. See here, track group is given here. Then this higher level indexing is able to have the entries for the group of tracks that are containing basically here, like how many tracks are there? 1, 2, 3, right? 3 tracks are there. Okay, so first this high level indexing is searched so as to find the group of tracks that may contain our desired file or desired record. Okay, so this higher level indexing, okay, this high level indexing can be used to reduce the search time. Why? Because an entry in the high level index, okay, will be able to point to the section of the index. Okay, hence this section of the index will be searched so as to find the section of the disk that may contain our desired record. Okay, here you can find the first track group and second track group, like having the low value and the high value, right? So now coming to the second figure. So this next figure is indicating the track index, right? Okay, so this track index indicates the low to high key value located on each and every track. Okay, so the first column here is the track. Hence, this track index will be able to indicate low to high value, high key value located on each and every track number 1, track number 2, and track number 3. So, for example, like on track 1, if you see the low value is 1 and high value is 13. And track number 2, the low value is 16 and high value is 31. Okay. And on track number 3, low value is 32 and high value is 43. Okay. So the track index for the track of group is now searched. Right. Understand this? The track index. Okay. So the track index for the track of the group is now searched to locate the track that may contain our desired record. Okay, fine. And what about this? So this track number 1 is having the low values 1 and high values 13. And similarly, the track number 2, okay, in group number 2, like we'll be having the records from 16 to 31. And the track number 3 will be having the low value as 32 and high value as 43, right? And this is the actual hard disk where we are storing our record. And I can access these records with the help of first searching the record in the track group so that I can locate the particular track. And in that track, the lower value of the track as well as the higher value of the track will be given by the track index. Okay, so you can explain this diagram by keeping in mind the example of how to search for a particular chapter in a large book. Okay, and the main point here is we can go for a use of higher level indexing if our index page or the content page is of say 100 number of pages are there, means in that case, right, I can go for a use of this higher level indexing. So the third method, so the first method was the sequential access file organization. Second method was the direct access file organization. And third method was index access file organization. And not to mention each and every concept or each and every kind of file system organization has got its own diagram. And the examination, they'll be looking at the diagram what we have written. Okay, so here, based upon the diagram only, you can score more marks. Okay, and once you have the diagram with you, means that becomes easy for you to explain the things in a better way. Hence, you can follow the main classification as well as the sub classification, okay, along with the relevant figures, diagrams that are being used in the book. Okay, and according to that, the sequential access file organization, like the figure is this one. Okay, and the main difference between the sequential and direct access is what? Respect to the figure. Main difference between sequential access file organization and direct access file organization is the use of something called as dummy records. Okay, and you can have this figure for the index sequential file organization. Okay, so the index is used to identify a section on the disk that may contain our record. And if the suppose if the file, right, or book is very much large, so then index will be having large number of entries. So for example, say like 1000 records are there. Okay, so at that time, what we do is the time needed to search for index will be large. Hence, to reduce the search time, what we can do is I can have higher level of indexing. Like index means index to index or content to content. Okay, so if index or content sheet itself is very much large, like having so many entries, means we can go for a use of index to index or content to content sheet. Okay, so the entry in the high level index points to the section of the index. Okay, means select track 1 or track 2 or track 3, and again we are searching in the particular track. So for example, so this track 2 is from 16 to 31, and track 3 is starting from 32 to 43 and so on. So this section of the index is searched to find the section of the disk that may contain